Hey everyone, it's Mrs. Slater and this is Drawing and Designing 3D Shapes. This is a review, so it's going to go quickly. It's just a way to review all the information that we did in this chapter. And at any points, pause the video or write down your questions because it does move fast. It's just meant to be a review. All right, let's go over some of the basics. We are working in 3D, so we need to understand what a dimension actually is. We can have only one dimension, and that's called 1D, because D stands for dimension. So 1D means one dimension. So if I just have a line, then really I can only measure the length of that line. If I have a rectangle, now I can measure the length and the height or the width, whichever one you're using at the time. So that is 2D. So again, the dimensions, I have 2 dimensions to measure. Now for a 3D shape, like a rectangular prism, I have 3 dimensions that I can measure. That's why it's called 3D. I could measure the length, the height, and the depth, for example. 3D objects cannot sit on an X and Y coordinate plane. That's because there's no depth. There's no way to add the 3D part of it, the third dimension. That's why 3D shapes are on an X, Y, and Z plane. So Z or Z, whichever way you say it in wherever you are. The 3D terminology goes like this. We need to know that the face of a 3D object is the part that any of the places that you can touch. It's the continuous flat part of that shape. I always kind of think of it like if I rub the shape, I could really feel like each shape in it. So here I'm feeling like the face, it's a cube, so there are multiple squares in this cube and each square is a face. The edge is the edge of the cube, and that part, you can't just put your whole hand on the edge. You would have to run it through with your finger because it's just the line, it's just the edge where 2 faces meet, right? So the face is the face, the edge is where 2 faces meet, and the vertex are the points where the edges meet. So you see how they kind of all connect to each other? Face, 2 faces together make an edge, 2 edges together make a vertex. The last thing we need to go over in the basic section is understanding the different types of graph paper. When we draw in 2D, if I'm drawing like a rectangle or a square, I use graph paper. We've seen graph paper before. But now we're drawing in 3D and we need a way to represent that third dimension. So we use something called isometric dot or graph paper. The isometric dot paper is simply just the same thing as the graph paper, and basically it's a dot where every single one of those lines meet, and then they take the lines away. That's how they're connected. So it really is the same thing. The isometric dot paper, the isometric graph paper, the lines are drawn at a 30-degree slope, or on a 30-degree, it's not on an angle. The angles that the lines create, though, are 90 degrees and 60 degrees. That's not super duper important, but just as sometimes it gets mixed up, it's easy to think that 90 degrees might be 30 degrees, but the slant of the line is the 30 degrees, and those lines create 90 and 60 degrees. Now onto the fun stuff. So isometric view and orthographic views are the main topics of this chapter. The isometric view means the 3D view of a 3D object. If I have a 3D view, it means that I have an X and Y and Z or Z. An isometric view of a 3D object is a drawing that shows 3 faces of an object at once using 30 degrees angles to represent the depth. So we're missing 2 of the faces on this cube, but we know what's going on based on the cube, and we're assuming this cube is finished. So we are seeing that this 3D shape is there. From these cubes, which in middle school we always use these 1x1 cubes, so we can assume that each of these cubes is 1 unit by 1 unit, we can build different shapes using these cubes. In the future, and obviously our world is not made up of 1 by 1 cubes, we start to add curves or 2 by 2 cubes by 3 by 3 cubes by rectangles, and we add different shapes. And that's because our world is much more creative than a 1 by 1 cube. But we have to start somewhere, right? So we're going to start with 1 by 1 cubes. These 3D shapes can then be shown in a 2D way, which is called the orthographic view. So the orthographic view basically is what's shown on the right here. I've taken this 3D shape and I've now represented it in 2D form, which is sort of a crazy idea to think of. We can represent the sides, the front, and the top. We can even expand that and also represent like the specific left view, specific right view, and even the bottom and top view. So the bottom view would be called the matte view, and the top view would be called the top view. The bottom view is sometimes called the matte view because if you were to place this object on a mat, they used to traditionally like build these objects on a mat. So sometimes it's called the matte view. For middle school, I will ask you any of these views, but I'm mostly focused on the front, top, and side view. And when I say side view, I'll specify which side. So something that is really important is, how do I know which view is which? Like, where do I start, right? The front view is always the view. It won't always be colored dark. That's one thing I would like to make sure you understand, that the front view isn't based on color. So here it's really nice because that front view is shaded darker than the rest of the object, but that won't always be the case. It usually will be the case because it's sort of like good practice, but it's never labeled. I will not label the front view. You should just know what the front view is. And that can be tricky for some students, but I think the more examples that we do, the more intuitive it will become. Last thing about the orthographic views, and that is that if I rotate the object in any way, even though the object is the same, this shape is the same in both of these images, the front view actually changes. If you look here, the front view for the first one is different than the front view for the second one. And the reason why that's really important is that when you draw the orthographic view for me or for your teacher, you want to make sure that you are drawing it based on how they have presented the 3D shape. If I present the 3D shape as the one on the top, you cannot draw the front view as the one on the bottom because we're mismatching what our shape is in space. We're accounting for how it is rotated and how it's also like placed in space, which is kind of crazy if you think about it. It's pretty crazy. Therefore, you've got to be careful that whatever view you're doing is how it's been presented to you, because your orthographic view represents that too. All right, last thing that kind of type of question you'll have is rotations. Just remember that a 90-degree angle is like if you have a circle, for example, and you cut it in half, it's 180 degrees. And then if I cut it in half again, it's 90 degrees. So 90-degree turn is like a quarter turn of a circle. When we have 3D shapes, I can ask you to turn it 90 degrees to the left and 90 degrees to the right. Now, if I'm drawing this on isometric dot paper and I'm redrawing my 3D shape, it can get really confusing really quickly because all of a sudden I'm trying to draw this circle and I'm moving it, and you can see here it's like the circle isn't really in 3D, and then if I try and move it, it's actually like now changed its angle in space. And that's because of the coordinate system. All right, so the coordinate system, later on in your mathematical careers, you'll be moving that shape along the different coordinates and rotating it along the different coordinates. But for middle school, what I want you to focus on is just literally turning it 90 degrees. So if you see the bottom image there, if I had that on a table, if I rotated it 90 degrees, that's what it would look like. This is a rotated 90 degrees to the right. And what that means is that I've taken this shape and moved it to the right. So let's see how the orthographic views change. Let's just see that for a second. Here is my original one. So my original shape that I have, and I'm going to tell you, okay, now I would like you to draw the orthographic views if I turn it 90 degrees. So I turn it 90 degrees, and now look, my views have completely changed. The front view is not the same anymore. And so this is the type of question that I'll ask you. I'll ask you to, I'll give you a 3D object and I'll say turn it 90 degrees to the right or turn it 90 degrees to the left, and then redraw the orthographic views. I'm not going to ask you to redraw it in a 3D space just because that can get a little bit more confusing. And that's it. That's everything orthographic views. I hope that this video gave you a good recap and like understanding summary of this chapter. Keep up the good work. Keep working hard.